Have you ever stepped outside at night, looked up, and felt that the moon looked unusually huge? Maybe you were taking out the trash, walking your dog, or coming home from work, and you paused because something about the sky felt different. Or perhaps you've seen photos online. Those dramatic images of an enormous moon sitting behind a city skyline, glowing brighter than usual. Even if you didn't know the term supermoon, you've probably felt that moment of surprise. The moon seems closer, larger, more intense, almost like nature is reminding you to pay attention. Maybe you've also noticed that people talk about these nights more often. Social media fills with pictures. Astronomers give interviews. News articles pop up with friendly reminders to look up tonight. And when the moon rises near the horizon, stretching above buildings or trees, you might catch yourself thinking, wow, that is definitely bigger than normal. But is it really? Or is something else happening? Why do some full moons look dramatically bigger and brighter than others? What exactly is a supermoon? And is it really as special as it seems? Why do our brains sometimes exaggerate the moon size when it's low on the horizon? And what does all this have to do with old seasonal names like cold moon, harvest moon, or wolf moon? Most importantly, if supermoons happen several times a year, why do they still feel rare, magical, and worth stepping outside to see? Open your mind, follow your curiosity. Welcome to the Center of Curiosity. Before we explore the deeper layers of supermoons, let's start with the basics. The moon orbits Earth in an oval shape. Scientists call it an ellipse. This means the distance between Earth and the moon isn't perfectly constant. Sometimes the moon is a bit closer. Sometimes it's a bit farther away. When a moon is closest to Earth in its orbit, we call that point perigee. When it's farthest, we call it apogee. The difference is large enough that a full moon at perigee can appear up to about 14% larger and about 30% brighter than one at apogee. That's the core of what people mean when they say supermoon. But the term supermoon isn't ancient or scientific. It was actually coined in 1979 by an astrologer, though astronomers later adopted the idea because it helped communicate something simple. A full moon that occurs near perigee looks slightly bigger and brighter than usual. However, you wouldn't notice this difference if you only glance casually. Our eyes adapt quickly. The moon doesn't suddenly look gigantic on its own. What really amplifies the effect is context, especially when a moon rises near the horizon and appears next to buildings, cranes, mountains, or shorelines. That's where our brains step in with something called the moon illusion, the tendency for low moons to look unnaturally large, even though they're not physically closer at that moment. And then there are the traditional moon names. Cold moon, for example, is simply the name given to the full moon of early winter in the northern hemisphere. It has nothing to do with temperature in space or scientific properties. It's cultural, seasonal, and deeply historical. Some years, the December full moon also happens close to perigee, and then you get a cold moon supermoon. So a supermoon isn't a mystical event. It's a combination of orbital geometry, human psychology, and cultural storytelling. But those three layers together create an experience that feels special, even though supermoons happen multiple times a year. Humans have been observing the moon far longer than we've had telescopes or scientific language. Ancient civilizations tracked its cycles with remarkable precision, using full moons to time planting seasons, migrations, religious ceremonies, and navigation. Long before electricity, the brightness of a full moon mattered. A brighter moon meant easier travel at night, safe for hunting, and extended working hours. The ancient Babylonians recorded lunar observations dating back more than 3,000 years. They noticed patterns in the moon's varying brightness but didn't know the underlying cause. The Greeks later recognized that the moon's orbit wasn't a perfect circle. Philosophers like Ptolemy attempted to model this motion, describing its variations using complex geometric systems. In China, lunar cycles were woven into calendars and agricultural planning. During the Han Dynasty, scholars documented subtle differences in lunar size. They saw these variations not as scientific anomalies, but as natural rhythms that carried cultural meaning. In medieval Europe, lunar phases governed religious holidays, trade cycles, and farming schedules. People didn't use the term supermoon, of course, but they noticed that some full moons felt bigger and brighter. On long winter nights, the December full moon, later known as the cold moon, became a marker of endurance, a reminder that the darkest days would eventually give way to lengthening light. By the early modern period, telescopes brought new precision. Astronomers like Johannes Hevelius and Giovanni Cassini charted the moon's surface and noticed its varying apparent size. In the industrial era, with railroads and mechanical clocks, lunar timing lost some practical importance, but fascination with the moon remained. Fast forward to the 20th century. In 1979, astrologer Richard Nall introduced the term supermoon, defining it as a full moon within 90% of perigee. The term spread quickly outside astrology. People liked how simple it was. In newspapers and science institutions, astronomers began using supermoon informally because it helped people connect with the sky. It wasn't a scientific classification, but it framed a natural phenomenon in a way that sparked curiosity. And when traditional names like cold moon, wolf moon, or harvest moon resurfaced in popular culture, the stories blended. Modern observers could look at a winter sky and connect with something ancient and astronomical at the same time. Now let's break down the mechanics behind a supermoon. The moon's orbit is shaped like an ellipse. That means there's a closest point, perigee, and a farthest point, apogee. The difference between these points is roughly 50,000 kilometers. Even though that seems like a lot, the moon is still extremely far away, over 350,000 kilometers on average. But that small percentage difference in distance is enough to change its apparent size in the sky. To visualize this, imagine holding a ball at arm's length. If you bring it 14% closer, it will look bigger. Not dramatically bigger, but noticeably so. The moon works the same way. However, a supermoon only occurs when two conditions line up. The moon must be at or near perigee. The moon must be full. Because the moon completes an orbit every 27.3 days, but becomes full every 29.5 days, these two cycles drift relative to each other. Sometimes they align closely, creating a supermoon. Sometimes they don't. This alignment leads to four effects people notice. 1. Apparent size. A supermoon can appear up to 14% larger than the smallest full moon of the year. 2. Brightness. With more reflected sunlight reaching Earth, it can look around 30% brighter. 3. Tides. Supermoons slightly amplify tides because the moon's gravitational pull is stronger at perigee. These are called perigean spring tides. They're usually modest, but can matter during storms or coastal flooding. 4. Visibility during moonrise. When the full moon rises near the horizon, our brains compare it with foreground objects, trees, water towers, city skylines. This comparison exaggerates its apparent size. This has nothing to do with physics. It's psychological. But when combined with a supermoon, the effect feels spectacular. And then there's the name cold moon. This is simply the December full moon, a traditional name from northern cultures that experienced long, cold nights during early winter. It doesn't mean the moon itself changes. But when a December full moon is also a supermoon, it rises higher in the sky, stays visible longer, and appears brighter than many other winter moons. That's why people notice it and share photos. Real-world supermoons are not as straightforward as the charts make them seem. For example, definitions vary. Some astronomers only count extremely close perigee full moons. Others use broader ranges, which is why you may hear different numbers about how many supermoons occur each year. Cultural influences also shape our perception. Western media often uses Native American full moon names, but many indigenous communities had multiple naming systems depending on region, climate, and lifestyle. Cold moon is just one version. Other cultures use completely different seasonal names. Geography matters too. A supermoon looks different depending on where you are on Earth. The angle of moonrise, local weather, air quality, and even light pollution all shape your experience. In cities with bright streetlights, the contrast between sky and ground can make a supermoon feel less dramatic. But in rural areas or near coastlines, the same moon can feel immense. The moon illusion also varies between individuals. Some people experience a strong sense of enlargement when the moon is near the horizon. Others barely notice it. Psychologists still debate the exact mechanism behind the illusion, but most explanations involve the way we judge distances on the horizon versus overhead. Even brightness can be deceptive. Humidity and dust scatter light differently. In some places, a supermoon can look warm and golden. In others, it appears icy white. These differences create a sense that some supermoons are better than others, even though the orbital mechanics are the same. Here's the part most people never learn. The moon's orbit isn't only elliptical, it slowly rotates or precesses over time. This means the alignment between perigee and full moon changes on an 8.85-year cycle. Some years, perigee occurs close to the moment of fullness, producing especially large supermoons. Other years, the alignment is off by many days, making supermoons less noticeable. This cycle explains why certain decades feel more supermoon-heavy than others. It's not random. It's rhythmic. There's another layer, too. The Earth's orbit around the Sun is also elliptical, so Earth is closer to the Sun in early January. This increases sunlight intensity by a small amount. When a full moon happens near this period and near perigee, the moon reflects slightly more total sunlight. This combination creates some of the brightest supermoons possible. Finally, because the December and January full moons climb highest in the sky for Northern Hemisphere observers, winter supermoons appear especially luminous. The cold air itself can even help. Clear winter nights tend to have less moisture, reducing light scattering and making the moon seem sharper and cleaner. So a supermoon isn't just bigger and brighter. It's the result of overlapping cycles. The shape of the moon's orbit, the timing of full moon phases, the precession of the lunar ellipse, the tilt of Earth, and even the distance between Earth and the Sun. These cycles weave together like gears in a celestial machine, producing moments when everything aligns just right. Let's bring it all together. A supermoon happens when a full moon occurs near perigee, the moon's closest point to Earth. This makes it appear up to about 14% larger and roughly 30% brighter than an apogee, full moon. The term supermoon is modern, but people across history noticed these variations long before the name existed. The December cold moon is simply the full moon of early winter, named by cultures that used lunar cycles to mark seasonal changes. When a cold moon aligns with perigee, it becomes a winter supermoon, high, bright, and visually striking. The moon illusion makes horizon supermoons look even larger, though this effect is psychological, not astronomical. And although supermoons happen several times a year, atmospheric conditions, cultural traditions, and human perception combine to make each one feel special. So the next time you step outside and notice the moon looking unusually large, you'll know what's happening. Maybe you're walking home, maybe you're taking the trash out, or maybe you're just glancing up for a moment. That sense of wonder comes from a combination of orbital mechanics, human perception, and thousands of years of storytelling woven into the night sky. What once felt like a mysterious, oversized moon now becomes a familiar companion, a natural rhythm you can understand and appreciate. Have you ever photographed a supermoon or seen one that felt unusually bright or enormous? What was the sky like where you live? Don't forget to subscribe for more curiosity-driven explanations.